Imagine a place in our solar system so mysterious that it took humanity over 6 decades to discover more than one of its secrets. A place where icy worlds lurk in the shadows beyond Neptune, waiting to reveal their secrets. On November 2, 2015, we caught our first real glimpse of this enigmatic realm. But now, the James Webb Telescope has pierced the darkness to unveil the sharpest image of the Kuiper Belt in history. What it found is nothing like we ever imagined. Pluto was the first Kuiper Belt object discovered, and for nearly 60 years it was the only one we knew about. On November 2015, the world got its first look at another Kuiper Belt object, a remarkable event that was one of the most remarkable images ever released from space. But that was just the beginning. The James Webb Telescope just captured the sharpest image ever of the Kuiper Belt, and it's not what anyone imagined. Located in the outer solar system, the Kuiper Belt creates a cold donut-shaped region behind Neptune, the 8th planet from the Sun. At first, its shape was the most interesting aspect, but it quickly became clear that this region would become one of the most fascinating aspects of understanding our solar system. According to astronomer Gerard Kuiper, whose work in the middle of the 20th century laid the foundation for our understanding of this post-Pluto region, he did not directly discover the Kuiper Belt. In 1951, Kuiper hypothesized the existence of objects beyond Pluto, but did not predict their specific properties or organization. Discovered by the astronomer Clyde Tombaugh in 1930, it was originally thought that Pluto was the 9th planet that defines the meaning of the Kuiper Belt. But as our understanding developed, it was found that Neptune's orbit creates the inner boundary of the belt due to its gravity. It was not until 1992, 62 years after the discovery of Pluto, that another Kuiper Belt object was discovered, revealing that Pluto was part of a larger population of objects in the solar system. This discovery led to the recognition of the Kuiper Belt as a region of various cold worlds beyond Neptune. Over time, more Kuiper Belt objects, KBOs, were discovered, leading to Pluto being reclassified as a dwarf planet by the International Astronomical Union in 2006. The Kuiper Belt extends the boundaries of our solar system to its outer reaches and is home to icy objects such as dwarf planets, asteroids, and comets. According to NASA, the material in the Kuiper Belt dates back to about 4.6 billion years ago, preserving the conditions of the early solar system. This zone is home to notable dwarf planets such as Haumea, Makemake, and Eris, as well as Pluto. Each of these celestial bodies provides unique insights into the composition and evolution of the Kuiper Belt and its role in the solar system. The Kuiper Belt differs from the Oort cloud, which is less populated and located even further from the Sun. Although both regions are sources of comets, the Kuiper Belt is more densely packed with objects, and its study provides critical information about the early days of our cosmic neighborhood. The NICE model, a theoretical framework, indicates that changes in the orbits of the major planets in the outer solar system cause the dispersion and loss of significant amounts of material from the Kuiper Belt. Today, the Kuiper Belt is gradually disintegrating, with collisions of objects causing fragmentation and the formation of smaller KBOs. Noteworthy missions such as Pioneer 10, Voyager 2, and the New Horizons spacecraft have expanded our understanding of the Kuiper Belt. Pioneer 10 was the first spacecraft to pass through the asteroid belt and Kuiper Belt, although it did not specifically study any KBOs. Voyager 2's study of Neptune's moon Triton and Cassini's Saturnian moon Phoebe provided valuable information about these distant worlds, some of which are thought to originate from the Kuiper Belt. The New Horizons mission made history by completing the first flyby of Pluto in 2015, providing an unprecedented view of the dwarf planet and its moons. The Hubble Space Telescope also played a key role in the discovery and study of KBOs. In 2014, it identified potential targets for the New Horizons mission, greatly increasing our understanding of the Kuiper Belt. The advanced infrared capabilities of the James Webb Space Telescope have now opened up new opportunities to observe and analyze this distant region, revealing unprecedented details about the composition and dynamics of the Kuiper Belt. The Kuiper Belt continues to fascinate scientists and provide a window into the solar system's past and the processes that shape it. The Kuiper Belt, named after the Dutch-American astronomer Gerard Kuiper, is a large region of our solar system that extends from about 30 astronomical units, AU, to about $50 from the orbit of Neptune. From the Sun, this remote region is home to many icy bodies and dwarf planets, of considerable interest to astronomers and planetary scientists. Kuiper's work in the middle of the 20th century laid the groundwork for understanding this region theoretically, but Clyde Tombaugh's discovery of Pluto in 1930 initially drew attention to this most distant part of our solar system. The discovery of Pluto was a monumental event because for decades it was considered the ninth planet in our solar system. Its highly eccentric and inclined orbit and relatively small size compared to other planets made it a unique and fascinating object. However, Pluto's status as a planet came into question when more objects were discovered in the Kuiper Belt, many of which were similar in size and composition. This led to the International Astronomical Union, IU, finally classifying Pluto as a dwarf planet in 2006, reflecting our evolving understanding of the structure of the solar system. The Kuiper Belt itself is a remnant of the early solar system, formed from material that never merged with a planet. This region contains a wide variety of objects, from small icy bodies to larger dwarf planets such as Haumea, Makemake, and Eris. These objects are thought to consist mostly of frozen volatiles such as methane, ammonia, and water, and provide insight into the conditions and processes that prevailed in the early stages of the solar system. Studying these objects can provide valuable information about the formation and evolution of our planetary system. The Kuiper Belt is also distinguished from the Oort cloud, another distant region of the solar system believed to be the source of long-lived comets. The Kuiper Belt is located at the level of the solar system and extends from approximately 30 to 50 Australian dollars from the Sun, while the Oort cloud is a spherical shell that surrounds the entire solar system and extends from approximately 2,000 to 100,000 Australian dollars. The Kuiper Belt has a higher density of objects and is a source of short-lived comets whose orbits bring them closer to the Sun more often than the Oort cloud point. One of the most important theoretical models that has shaped our understanding of the Kuiper Belt is the Nice model. This model, named after the French city of Nice where it was developed, suggests that the giant planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, experienced significant orbital migrations early in the history of the solar system. These excursions caused gravitational interactions that scattered large amounts of material into the Kuiper Belt, causing the current distribution of objects. According to the Nice model, the Kuiper Belt originally contained much more material than it does today, and much of it was lost due to these gravitational interactions. The Kuiper Belt gradually breaks up, and collisions between objects cause the formation of smaller fragments. Some of these fragments may become comets, while others remain as debris in the belt. The total mass of the Kuiper Belt is estimated to be only about 10% of the mass of Earth, but it contains a huge number of objects, each with unique characteristics and histories. Studying these objects can provide valuable information about the processes that formed our solar system. One of the most important missions that expanded our understanding of the Kuiper Belt is the New Horizons mission. Launched by NASA in 2006, New Horizons made a historic flyby of Pluto in 2015, providing the first close-up views and information about this distant world and its moons. The mission revealed a complex and dynamic system with features such as this encounter provided valuable information about a small, primitive object, providing insight into early times. Conditions of the solar system. The Hubble Space Telescope also played a crucial role in the study of the Kuiper Belt. Hubble observations have helped identify and characterize many KBOs, providing important information about their size, shape, and composition. In 2014, Hubble identified 3 potential targets for the New Horizons mission, highlighting its importance in the design and execution of deep space missions. Hubble's ability to observe dim and distant objects has made it an invaluable tool for studying the Kuiper Belt and other distant regions of the solar system. The launch of the James Webb Space Telescope, JWST, in 2021 will be the next step in the study of the Kuiper Belt. Thanks to its advanced infrared capability, JWST can observe objects in the Kuiper Belt in unprecedented detail, providing new insights into their composition, temperatures, and other physical properties. Infrared observations are particularly useful for studying the ice compositions of KBOs, since many of their most important spectral features lie in the infrared region. JWST's observations are expected to greatly improve our understanding of the Kuiper Belt and its role in the solar system. The study of the Kuiper Belt is not only important for understanding our solar system, but also has wider implications for the study of planets around other stars. The discovery of exoplanets and debris disks around other stars has shown that many of the processes that formed our solar system are common to other planetary systems. By studying the Kuiper Belt, we gain insight into the formation and evolution of planetary systems in general, providing a broader context for understanding our place in the universe. In conclusion, the Kuiper Belt is a fascinating and complex region of our solar system that offers valuable insights into the early conditions and processes that formed our planetary system. From the discovery of Pluto in 1930 to advanced observations by the James Webb Space Telescope, our understanding of the Kuiper Belt has evolved significantly over the past century. Studying this distant region remains a priority for astronomers and planetary scientists, as it holds the key to understanding the history and evolution of our solar system and beyond.